This video will be on solving exponential equations, and we're going to utilize a common base in order to do this, and also exponent properties. Right here we have 2 is being raised, 2 is the base, it's being raised to the x plus 1 power, and it's equal to 8. So we need to figure out a common base that we could use in order to work with this exponential equation. And we can do this because 8 can be expressed using that same base as the left side of the equation. If we take that base of 2 and raise it to the third power, that's the same as 8. 2 to the third power is equal to 8. So I can make that substitution and then bring down what was on the left side. And now we can solve this equation because we have the common base that we can compare. And what really happens is the common base, as long as there is one, can drop, and then the exponent part comes down. So x plus 1 would equal 3. We're going to be looking at the exponent parts. And then we would solve this as we would with a linear equation. So x must be equal to 2, which makes sense because if we plug this in, 2 to the 2 plus 1 power is the same as 2 to the third power, which is 8. That was the first one. The second one, we're going to use a very similar approach. And it's important to use our exponent properties and also to not mix it up with multiplication. There is some aspects of multiplication that are used, but using powers is different. The second question is 4 is raised to the 2x plus 5 power. So we're not going to go ahead and we're not going to multiply here. We're not going to multiply or distribute 4 to the 2x plus 5. We're not going to do that because it's not multiplication happening here. It's a power or a base raised to a power. And this is equal to 8 to the 3x power. And we need to think about utilizing a common base. I can express 4. I know that I could change that to be 2 squared. And I'm going to put that in parentheses. And that 4 is raised to that power, so I'm going to have to bring the power up here. I'm not going to confuse it with multiplication. I'm going to treat this as a power. All I did was make a substitution for 4, and I used 2 as the base, 2 squared. And if I use a base of 2 over here, I want to try to use the same base on the other side of the equal sign, on the right side. So instead of putting 8 as the base, I'm going to put 2 cubed, which is equivalent. I'm going to trade that out and substitute it. And this is raised to the 3x power. And now we're going to go back to the left side and look and use our exponent properties. We have a base raised to a power that's raised to a power. So this is the power rule. And the power rule says that you can keep the base, keep the 2, and multiply the powers. Now you can multiply the powers because we're utilizing our exponent properties. And we're going to be multiplying 2 by 2x plus 5. 2 times 2x is going to be 4x. However, the answer that we get is going to go as the exponent. And then 2 times 5 would be plus 10. 4x plus 10 is the entire exponent. It should be as a superscript. It should not be on the same line as the base. And this is equal to, over here we could use exponent rules and use that power rule again. So the name of that rule I'll write over here. It's the power rule. That's the one utilized here. And when you have a power raised to another power, you can multiply the powers together and keep the base as a 2. So that's going to be 9x now. Since we have the common base, we can drop the base and look at the exponents. 4x plus 10 is equal to 9x then. And this is only possible because they have that common base. And solve for x as we normally would with a linear equation. I'm going to subtract 4x from both sides. And then 10 is going to be equal to 9x minus 4x is 5x. Divide by 5. In order to undo the multiplication that was there, we use division, and then we would get 2 is equal to x, which is your solution, which makes sense. 4 raised to the 2 times 2 would be 4 plus 5. So 4 raised to the 9th power is what that's going to be when we substitute. Is that equal to 8 and then to the 3x power? So that would be the 3 times 2, which would be a 6. And then on your calculator, you can test that out and see if that's true. It's always good to check your answers. So 4 is raised to the 9th power. The value that you get would be 262,144. And then we want to see if that's the same as 8 to the 6th power. And it does get the same response. So we know in our check that the answer is correct. Our answer is x equals 2 here. The other ones will be shown in another video so that these aren't so long in length.